This is the video recording for homework 3, problem 2, for probability in a stochastic process. The problem setting is x is uniform in range a to b and y equals to x squared, and we need to find and draw f y and capital F of x. And the second question is given the value of a and b, which is -1 and 3 separately. We need to find and draw f lower letter f of y and capital F of y, and we also need to find e of y. So for the first question, since x is uniform in the range a to b, we can easily get the density function of x is to be f of x is equal to 1 over b minus a when x is between a and b, and it's 0 otherwise. So we can directly get the capital F of x to be 0 when x is less than a, and is equal to 1 over b minus a times the sum of x plus 1 when x is between a and b, and the probability of x is also equal to 1 when x is equal to or larger than b. And so we draw the sketch the graph of capital F of x and density function and lowercase f of x. They are separately like this, as we can see that as we can see the probability of x is changing. The value of capital F of x is changing from 0 to a certain value and to 1, and the value of the density function is equally and uniformly distributed on the range of from a to b. For the second question, where a is equal to -1 and b equals to 3, we can derive substitute these two values in and get the exact value of the density function. And for y equal to x squared, we can get that there are three different situations where y could take value. The first is when y is less than 0 or y is larger than 9. This is accordingly relating to the density function of x. These two ranges are out of range where f of x is equal to 0. So f of y is equal to 0 in these two ranges, and for y is equal to or larger than 0 and equal to or less than 1. There are actually two roots for the equation y equals to x squared. Excuse me. These two roots are exactly x is equal to plus or negative, positive or negative square root of y, and then we need to derive the density function of y. It is equal to the sum of f of x1 over the absolute value of the gx1, taking the first derivative, and also the other term is f of x over the absolute value of the first derivative of gx2, and we can get these two values as 1 over 4 over absolute value of -2 square root of y plus 1 over 4 over the absolute value of 2 times the square root of y, and this is actually 1 over 4 times square root of y. And when y is larger than 1 but less than or equal to 9, there's only one root for the equation of y equals to x squared, which is x is equal to square root of y, where x and y are both positive numbers. So the density function of fy is equal to fx over the first derivative and absolute value of gx, which is 1 over 4 over the absolute value of 2 times square root of y is equal to 1 over 8 times square root of y. And so we can write this density function of y in the like a more general form, and we can get the a capital F of y is equal to 0 when y is less than or equal to 0, and it is equal to 1/2 times square root of y. For y it is between 0 and 1. This value can be directly get taking the integral of lowercase f of y times y. And similarly, we can also get the value for y is equal is between 1 and 9. This number value should be 1/4 times the sum of square root of y plus 1. And in order to find the expectation of y, we can use this definition. It's equal to the integral of y times density function lowercase f of y, and during like simple rounds of calculation, we can get the value is finally to be 7/3. And this is the end of the question 2.